Okay, next page, please. There we go. Of course. Right. Okay. So, what we're going to look at now we're going to look at practical problems using exponential and logs. So there aren't any new formulas, it's just about using the formulas. Okay, so for example, let's see. Something maybe like in chemistry or biology or something, you have a substance here, and its temperature in Celsius, so its temperature is equal to 30 plus AE minus 0.2. Well, actually, let's make it a little bit more difficult. AE BT, for example. So what I'm telling you here in this question is that the temperature is given by this formula. The only problem is you don't know what the A and the B is. Okay? So I then tell you it starts at 70 Celsius and then 10 minutes later it's at 60 Celsius. So this is enough information now to find the A and the B. I tell you it starts at 70. So what that means is 70 should equal 30 plus AE0. The small t is 0 because at the beginning that means t is 0. So that gives me the A. A is 40. So now we have this formula.
Why do we
E power 0 is 1. Now I want to find the B. I'm told 10 minutes later it's at 60. So that means this will be 60 when the t is 10. So now I can get what the B is. So I have 30 equals 40 E10B. 0.75 equals E10B, because you divide by 40. How can I cancel the E? With a log. Natural log. So now I get log 0.75 equals 10B. So B is log 0.75 over 10. What's that, please? Minus, what is it?
Minus 0.028.
0.028. So now you have your formula for the temperature. The temperature equals 30 plus 40 e power minus 0.028 T. So now the second part of my question is, what is the temperature after 20 minutes? So now that you know the A and the B, it's very easy to find the temperature, because you just have to put the small t equal to 20. So you have T equals 30 plus 40 e power minus 0.028 times 20. So what does that equal? What do we get? Come on. That is
100.0269.
100 point.
100.0269.
So about 100 then. Are we sure? Because that would mean. Thank you. That sounds better than Louise. 52 point. Yeah. Because if it was 100, it means it got cooler and then increased back to 100 Celsius. So, at the beginning, what was the temperature? 70, and then after 10 minutes, 60, and then after another 10 minutes, so 20 minutes in total, 52. And as a matter of interest, when you have things like cups and samples and so on, the formula for its temperature equals the room temperature plus AEBT. That means that, or I should say, that's how come I have the 30 here in the formula. That's the room temperature. What do you think affects the A and the B? No, but I mean like in this example here. The A. Well, the A depends on the temperature of the sample at the beginning. Because if you look here, yeah, I got, when the T is 0, I get room temperature plus A equals the temperature at the beginning. So the A basically reflects how hot it is at the start. So what do you think the B represents? Well, the B is how quickly it cools down. So if you look here, this B here, the bigger it is, the quicker it cools down. And the minus means it's cooling down. Whereas if it was positive, it would mean it's warming up. Okay? So, this isn't really important for what we're trying to do today. But I just want to show you where these types of formulas, what they mean. So this is a formula for temperature. Room temperature plus this piece here. It always behaves like this. So when you do your chemistry or your biology labs, and I think you have to measure temperatures, in fact it will follow this formula. Temperature, time, and it will decrease like this until it reaches its room temperature. Okay, let's have a look at another problem. Okay, do you have this taken down? Yeah? Okay. So here is some, let's see, let's make this apple juice. 200 milliliters. Have you done pH level in chemistry? pH? You know pH? Is apple juice acid or base? Acid. So its pH should be what? Under what? Yeah, under 7. So for apple juice, the pH level, we'll say it's 4. Now if you don't know what pH is, that's okay. It's not really important. It's only if the chemistry students have seen it. Have you seen pH? Yeah. Do you know the formula for pH? No? No? I'll tell you. The formula for pH is minus log base 10 the concentration of positive hydrogen. Yes. Yes. Okay. So from this information, it's possible to work out how many positive hydrogen ions are in your apple juice with very little information. The only thing you know is how much apple juice you have, 200 milliliters, and the pH level. And I think you can measure the pH by the coloured paper, isn't it? You put some paper in it, then it changes colour, so you can measure the pH. Anyways, with this information, we can actually work out how many positive hydrogen ions are in the apple juice, okay? So firstly, what do we know? We know that this here is 4 equals, minus log base 10 H plus. Now I'm looking for the H plus.
So make it X, then?
Yeah, you can make it like X, yeah. So 4 equals minus log base 10x. Now if you want, you can take this minus up the top. So you get 4 equals log 10x minus 1, if you like. Or you could have taken the minus over to the left, doesn't really matter. So you know 10 to the power 4 equals x minus 1. So you get 10,000 equals 1 over x. So x equals 1 over 10,000. Now what does x represent though? Concentration of hydrogen, this is 0.0001. Concentration of positive hydrogen ions is 0.0001. What's concentration? The formula or the definition of concentration? It's moles per liter. Yeah, the maths teacher shouldn't know more about this. Moles per liter. Okay, so what we have is 0.0001 mole of positive hydrogen per liter. Now, how many litres do we have of apple juice?
2.
No, 200 millilitres.
So 0.2.
Yes, we have a fifth of a litre. So if I divide this by 5, I get how many moles I have per apple juice carton. So that's 0.00002 moles per 200 millilitres.
Why do we divide it by 5?
By 5? Because we have a fifth of a litre. We have 200 millilitres. So we have 0.000002 moles of H plus. Hey, this is good timing. We're working out how many positive hydrogen ions we have in apple juice.
Oh, you know, they're in practice.
Yes,
No
yes.
problem.
They were a little bit. They were a little bit shaky on what concentration is. Yeah. No, I won't tell you anymore. All right. So we have 0.0002 moles of positive hydrogen ions. But how much is 1 mole? How do we go from mole to atoms or molecules? How much is 1 mole? What's the name of the constant? Avogadro, yeah. So if I just multiply this by, what is it, 6.602, 10 to the, no, minus, think positive, 33, yes, of H plus. Can you type this in? What do we get?
2 times 10 to the 19.
1 point?
2 times 10 to the power of 19.
So in other words, we have roughly 10 to the 19 H positive ions. What's H positive? That's just one hydrogen with no electron. Sorry, one proton with no electron. Do we say it has a neutron or not? No. So anyways, roughly 10 to the 19 protons, basically, isn't it? Yeah, there's no electrons. Here, I'll draw it. Oh, no, we'll just leave it there. Alright, so 10 to the power 19 H plus ions. That's how much we have in our apple juice. Okay. Another example now. Have you used this formula? Base 10, log base 10? I mean, have you seen this?
Yeah,
You've seen this before?
Yeah.
Are you sure? This year?
No.
Previously. Okay. Okay, let's have a look at another example. Yes, another one.
Is this going to be like this in the exam?
Yes. I've seen a question like this. Except, in the exam, of course, they'll give you this formula. And they'll give you this number. Oh no, they wouldn't do that in the exam. Sorry, the exam would stop here. Once you have the X.
Okay, so still here in the exam, so.
Yes. But since you are also chemistry students, I thought you might like to see me finish it. Okay?
Yeah, I found that.
Yes. You enjoyed it. That's great.
Yeah, professional.
Okay. Next now. We'll talk a little bit about carbon 14. So do you know what carbon 14 is? Do you know it? It's an isotope. What's special about it?
It has 2 extra neutrons.
Ah, that's not special about it. What's special about it? No. Carbon 14 is in everything that's living. All living cells have carbon-14. Yeah. And when something dies, its carbon-14 reduces. So what happens is, carbon-14, at the beginning, when the animal, plant, or person just dies, the carbon-14 is at 100%, or whatever the amount is. But then after time, it decreases. What people do is when they find some animal that's dead, they look at how much carbon-14 is inside of it, and then they can work out backwards how long it was dead for. What's special about carbon-14 is this graph here is of the shape AEBT. It decreases exponentially. In fact, carbon-14 will half every 5730 years. So what this means is after 5,730 years, there will be 50% left. So you can see that carbon-14 decays very slowly. It takes nearly 6,000 years before the carbon-14 has reduced by 50% in the dead animal. Okay, can I go down to an example using this then?
Yes.
Yeah? Okay. What's really nice is when people find old paper, okay, we know what paper is made of now. Paper is made from trees. Okay, but old paper, what did people used to use in the past, a long time ago? What did they use, do we know? Yeah, but that was specific to Egypt, just more in general.
For messaging.
For writing books, what did people write on? They didn't use trees. Leather, yeah. So they would use like skin maybe from animals. Okay, so that means that this paper was alive because it came from an animal. So what you could work out is how old the paper is by how much carbon-14 is left. So for example, let's say here there's 80% C14 remaining. That's how much carbon-14 is left in this paper. So we can work out how old the paper is, or at least when the animal who made the paper died. So we have carbon-14 is equal to AEBT. How much carbon-14 do we have at the start, when the animal just died? 100%. So we have 100% equals AE0. So then what does A equal? 100%. So we have carbon-14 equals equals 100% EBT. Now remember I said after 5,730 years, how much carbon is left? 50%. And this is true. This is always true. So we have 50% equals 100% e power 5730b. So if I divide by 100, I get 0.5 equals E5730b. Now if I put a log on both sides, I get log 0.5 equals 5730b. So can someone type that in please? It should be negative and it should be quite small. So what do we get for b? Minus 1? Yeah, okay, minus 1.2. 10 to the minus 4, so that would be minus 0.000121, something like that. Okay, that's the B. So now we have our formula. We know that carbon 14 will equal 100% e power minus 0.000121 T. So now we can find the time. What do we put the carbon 14 equal to now? 80%. Now we can find the time. So we have 80% equals 100% e power minus 0.000121 T. So you get 0.8 equals e power minus 0.000121 T. I put a log here and a log here. Let me just check my battery. Yeah, it's okay. So I get log 0.8 equals minus 0.000121 T. So we can finish now. We get time T equals log 0.8 over minus 0.000121. So what's that number, please? $1,844. Okay, roughly. So you have this paper, or at least the animal which made the paper, died 1,844 years ago. And this really is what people do when they want to date how old artifacts are. So this is actually called carbon 14 dating, C14 dating. Okay. Let's see how we do. What are you doing in biology at the moment? Cell structure. Have you done cell growth or anything? No. I'll give you a small one to try here. I think bacteria double every 15 minutes. I think so. So if T equals 0, you have one bacteria. If T equals 15, you have 2 bacteria. And then when T equals 30, you have 4, and so on. So my question for you is, I want you to tell me how long until I have 1 billion bacteria cells. Okay, so that's my question. I want you to try. How long until I have 1 billion bacteria cells? Okay, so try that now. It shouldn't take you too long. And I'll give you a little bit of a hint just to get you started. Bacteria grows exponentially. So you could use this formula. The number of bacteria, let me call that N actually, the number of bacteria is equal to A, E, B, T. Okay. If you're working on it, you can keep working on it, but I'm going to do it now. If you need help, you can look up. So you know at the beginning, there's 1. So you have 1 equals AE0. So then A equals 1. So you get N equals EBT. And you know, after 15 minutes, there's 2. So you get 2 equals E15B. You put a log on both sides. So you get log 2 equals 15B. So B equals 15 over log 2. What's that, please? Thank you. Sorry, that's upside down. Log 2 over 15. What's that, please? 0.046. Okay. So now you have the number of bacteria equals e power 0.046 t. And how many bacteria do I want? Power 9, yeah, 1 billion. Equals e power 0.046 t. So just like before, we'll put a log on both sides. But if you want to make this a little bit neater, this is log 10 power 9 equals 0.046 t. So in fact you can take the 9 down. And we can take this down. So 9 log 10 over 0.046. 448.56 minutes. So divide that by 60. Tell me how many hours that is. 7.5 about hours.
We get billions of things.
Yep. Yep. Now, this formula is not perfectly realistic because I'm sure if you haven't done it, you will do a column that when you look at time and bacteria, yeah, it grows exponentially, but then it doesn't continue to grow. What happens? Yeah, it levels off here. And the reason for this is less food, less energy, less resources. So what I'm saying is, at least for maybe this part here, the growth, you could say it's, sorry, this should be N. You could say it's AEBT, but then what will happen is it will reach a limit here. Okay. Have you seen this graph with column? For what? For enzymes, yeah. The enzymes, just like the bacteria, they'll increase like this, and then what happens is around about here, this is when they start to reach its capacity, its limit, and then here is its maximum. But at least from here to here, you can say it's this graph. Exponential graph. Okay? Okay, so the best thing you can do now is to practice these. There's only 7 questions there, so you should practice all 7 of them. And I suspect in the tutorial maybe we might do some of these. But try your best. Just so you know, number 1, 1, 3, 1, 3. No, I'm just telling you which ones came up in the exam.
Oh.
So 1, 3, 5, 6 and 7. Yeah, pretty much most of these are exam questions, like exam questions. Yeah, pretty much all of them.